Welcome to Common Logarithms. So we're going to talk about solving some different types of equations today. First thing before we do that, we need to talk about, well, how do we find the logs of equations using the calculator? So what we do is we have the change of base formula. What you do, you can actually use the log button on your calculator just as long as you take the log of the large number divided by the log of the base. And that will always give you the proper decimal you would need. So we're going to start by finding that. So we want to express log base 5 of 140 in terms of common logs. So we're going to write the fraction. So basically we're showing our work, and then we're actually going to find the answer. So first thing, the one that goes on top should be the log of the large number. Now just the bigger number. It doesn't mean because 140 is bigger than 5. And divided by log of the base. So then what we need to do is put in our calculator, use the log button. So log of 140 is approximately 2.1461. So 10 thousandths would mean to go 4 numbers past. And then the log of 5 would be 0.6989. And then we divide those out. And we get 3.0707. So you can actually put in the log of 140 divided by log of 5 in your calculator, and you would end up with the same answer. So let's see if you guys can try this. So I want you to see if you can find the log base 5 of 16, express it in terms of, or how you would divide it, and then give me the actual decimal. Okay, now let's go ahead. Let's actually use it to solve some equations. So we're going to have some equations that might have an exponential or a log, and so today we're actually going to practice using a log or exponential as an opposite operation. So first step we have is you get the exponential or log by itself. So if there's anything being added to it or subtracted, multiplied, whatever, you have to move it over first. Then you're going to switch the forms. So if it's log, switch to exponential, or exponential, switch it to log. And we're going to solve for x. Most of the time we're going to have to use our change of base formula and then finish solving for x. So let's go ahead and look at our first example doing this. So we want to solve 5 to the x equals 62. So as I noticed, my exponential is already by itself. So since it's exponential, I want to switch it to log form. So I have log, my base is 5, of 62 equals x. So here's where we're going to use the new thing we learned, the change of base formula. So in your calculator, you're going to put in log of 62 divided by log 5, and that's going to give you what x is. So when we divide that out, I get a 2.56 answer for the x. Okay, next. This one, if you notice, I have an actual expression up in the exponent. But the exponential is by itself because the only operation there is up in the exponent. So I am going to go ahead and change it from exponential to log form. So I have log. My base is now 2.9. Then of 8.1. And then I'm just going to put the whole exponent of a minus 4 directly after the equal sign. So again, I'm going to use the change of base formula. and do log of 8.1 divided by log of 2.9. And when I put that in the calculator, I get an answer of 1.96 equals a minus 4, so that's just going to drop down. To finish solving for a, of course, I have to add 4 on both sides. And then so I get 5.96 equals a. Okay, so now we're going to talk about some equations that have exponentials on both sides. So what we're going to do is we're going to write log in front of both of the equations. So that's the first step. And then we're going to use our properties of logs, and I'll show you what I mean. So there's a few steps that we need to go through here. So let's go ahead and go on to the first example. These are inequalities, but they're solved the same way. So what we're going to do is we're going to first write log in front of both of these. So it'll be log of 3 to the 7x is greater than log of 2 to the 5x minus 3. And I am using just log base 10, so it'll be something we can put in our calculators. So if I use the rules that we know about exponents, this exponent now goes in front of the log, and same with this exponent. So I'm now going to write it as 7x times log base 3 is greater than 5x minus 3 times log of 2. Now if you notice, I put parentheses around the 5x minus 3. Well, what's going to happen is I have to distribute that log of 2. So this turns into 7x log of 3 is greater than 5x log 2 minus 3 log 2. So I distributed that log 2. Now I am still going to have to solve for x. So when we have variables on both sides, remember we have to get them together. So what I have to do is subtract that 5x log 2 from both sides, so it turns into 7x log 3 minus 5x log 2 is greater than negative 3 log 2. And then what I'm going to do, since I have to isolate the x, I'm actually going to take it out like a GCF. So I'm going to take it out of both of those, and I only take out an x because that's what I'm trying to get by itself. So it'll be 7 log 3 minus 5 log 2 is greater than negative 3 log 2. And then to finish getting x by itself, I'm going to divide by that 7 log 3 minus 5 log 2. And what we're going to do is we're going to put this whole big thing in the calculator. So x is greater than negative 3 log 2 divided by 7 log 3 minus 5 log 2. So when I put it in the calculator, I end up with x is greater than negative 0.49. And that's my answer. So I know that's a rather long process, so we're going to go ahead and try it again, just to make sure you get the idea. So same type of problem. So if you remember how we started this, we put a log in front of both of these. Then we take our exponents. We know the exponents move out front. So it would be 2x log 3 is greater than or equal to, we keep the x plus 1 in parentheses, log 6. I have to distribute the log 6, so it would be 2x log 3 is greater than or equal to x log 6 plus log 6, because 1 times log 6 would be log 6. The next thing, you have to move the x terms over. So to move this term over, I would subtract it. So it turns into 2x log 3 minus x log 6 is greater than or equal to log 6. And again, the whole idea is we have to get x by itself. So I'm going to factor out that x from both of these. So it'll be 2 log 3 minus log 6 is greater than or equal to log 6. And the last thing is divide by that 2 log 3 minus log 6 to finally get that x by itself. So my answer would be x is greater than or equal to log 6 over 2 log 3 minus log 6. Now the big thing when you put it in your calculator, what I would suggest, use your parenthesis button. So make sure and put a parenthesis before this and after that, and then you should get the answer. And on this one I ended up with an answer of 4.42.